Hi data scientists, welcome back to Breath of Data Science. I'm Tarun, I have a master's in data science and I'm currently working as a data scientist in Germany. I created this channel to share my knowledge of data science, programming and related things. So far I have created a few videos on data pre-processing or machine learning conceptual theories and simple linear regression in Python. But there has been one thing in common, and which is if you're ever going to work with data, you are more or less going to use something like pandas to work with the data that you have. And in this particular video today, I will talk about some indexing best practices in pandas series and how you can perform those efficient indexing. As I said, we are going to talk about the best ways to perform indexing in pandas series, and you should be aware that an index in pandas series must not be a whole number. It can be strings, for example. So let's start to see some examples. So let's first import pandas as a first step, and then let's create a pandas series with the object, let's say George, and then I define my data points. So it has two data points as integers. Then I define the index. So I can define index as let's say strings, as I said. So this is my index, and then I name my object as, let's say, George songs, for example. And then if I run what does George has, so you can see it has two data points with the values 10 and 7, and two indexes 1968 and 1969. So here if you look, I passed the index type of the variable George as strings, so which is indicated as objects within pandas, and you can see that using the .index method. So if I call the George.index, you'll see that okay, its indexes are 1968 in string form and 1969 in string form, and the data type is object. So now the next method that is available to us in pandas series is to identify whether an index has duplicates or not. And to do that, the method is called isUnique. So if, let's say, we check on George if it has any duplicate values or not, so I can call isUnique on George. So it says, yeah, George is unique, but let's create another series with a duplicate values. So I have 3 elements now. So if I run .isUnique on this new panda series, it says that the entire series is unique, but if I run this on its index, then you can see that it says false. And similar to a NumPy array, a series object in pandas can have both indexed index values along its axis. So what it means is I can see any object or any data point within the series using normal slicing that we are used to in NumPy or simple vanilla Python. So if I do, let's say, George 0, then I'll see the first entry, which is 10, as you can see here, which is the first data point that we provided. The indexing rules are somewhat complex in pandas, but they behave more like a dictionary, sort of from an understanding point of view. But in the case where a string index label is present rather than an integer-based indexing is used, the behavior will fall back to the Python list indexing. So what it means is, since I have not used integer-based indexing in my George object, I have rather used string-based or object-based in pandas terms. I can get my objects from the series like this as well by passing in the index element directly. This series can also be indexed using position, which is integers, and even though it has string index entries, so the first item starts at 0 and the last item is at key -1. So as we saw in our this cell, that you can index using normal integer-based indexing, and you can also access it using Python-based last element of -1. So just note that if the index is already using integer labels, then the fallback to position-based indexing does not work. So what does this mean is, So let's create another series object. This time we'll have integer based index in our element, in our series, sorry. Then let's provide index and let's keep it integer with the same value that we had last time as well. So if I try and run, say, last element of this, then I get an error that this key is not present in this particular series series object. And this is so because the index in this particular series is already integer based, and hence we cannot use normal Python based indexing to do this kind of slicing. But if I did the actual index here, which is, let's say, 1968, you can see that, okay, it gives me the correct output. So now let's see how you can actually locate elements within a series. So you use .loc and .iloc for that in Pandas series. So these access methods are optimized data access methods, and these two attributes allow label based and position based indexing respectively. So what it means is with .loc you can access data using label base, and with iloc you can access data using position based. So when we perform any index operation using the .iloc attribute, it does a lookup in the series object based on its index position. In this case, pandas will behave similar to a Python list. Pandas will also raise an error if there is no index present at that location. So let's see it in action. So we work with our George series. So let's try george.iloc 0. It gives us output 10. If we do george.iloc -1, it gives us 7. If we try george.iloc 4, it gives us an error because this index is out of bounds because we had only two elements in our series George. And if I try with the actual index name or the value, it will tell us that we cannot locate a single item in this particular way using the index that its actual value, because as I said, using iloc it behaves similar to a Python list. So in addition to pulling out a single item from a series, we can also slice a series object just like a normal Python list, and you can also pass in a list of index locations to the index operation. So what it means is for in the same .iloc attribute, I can provide something like this, and it will give me everything starting from 0 till 2. But let's say if I do this, then it will only give me the first element, which should be the correct. And if you want to do it in another way, you can do it like this. So both statements, this one and this, they will give you the same results. And this is so because in the second way you are also indexing the first and the second element. But if you try and do this, you'll get an error because the index 2 is out of bounds because we only have two elements in our series. So now .loc, let's look at .loc examples. And .loc is supposed to be based on index labels, not the positions. And as such, if you want to look it into Python's terms, it is analogous to Python dictionary based indexing, though it has some additional functionalities available as it can accept Boolean arrays, slices, and a list of labels, which do not work with a normal Python dictionary. So if we have a look at a few examples, so let's start with the first one. So if we write the actual index value here with the .loc, it works, but it did not work with iloc because .iloc is position based, but .loc is index label based. And the same I can do for, say, 1969, it will give me the correct result. If I do for 1970, then it will give me the key error because my series object George only has two indexes, 1968 and 1969. And if I try, let's say, a position based index, it will also give me a key error because my indexes are string based, and since I'm using .loc, it works on the label based, not on position based. And then I can do something like in this, like something similar to this, where I can pass in multiple index values at the same time, and it will give me the correct results. Then I can also try something like, let's say, Then it will also start picking the data from 1968 and forward. So if you are still confused by .iloc and .log, remember that .iloc is based on index starting with IA position, similar to a Python list, and .log is based on label starting with I, and it's similar to a Python dictionary. So far now we have talked about .log, .iloc. You can perform slicing with these attributes, and what slicing does is it attempts to pull out a range of index locations, and then the result is a series rather than a scalar item at a one singular index location. So slices, they take the form start and then end and stride. So what this means is you provide a starting index, then you provide an end index, and then you also provide at the same time how much do you want to jump when you move from starting towards the ending index. So, and they are all integers, and square brackets represent optional values. So this stride is optional. And let's look at this particular example. So what I have here is if you have 0 to 1, then you only want the first item. If you have colon 1, then you want the first item, since the default start is 0, and the last index is non-inclusive. If you have colon -2, then you want from start until second to the last item, and if you have colon 2, then you want from start to end, and you want the every second item, right? And we saw this example here in this particular instance, where we wanted everything starting from 0th position till the second position, till the index 2, not the second position exactly, till the index 2, because 3 is not inclusive in Python slicing. So now let's look at Boolean arrays and how you can use them in your Pandas series. So a slice using the result of a Boolean operation is called a Boolean array. It returns a filtered series for which the Boolean operation is evaluated. So let's create a Boolean operation called mask, where we want to identify only objects within George which are greater than 7. So let's see what happens is, okay, we found two indexes, 1968 and 1969. One of them is true because it had the value 10, and 1969 which had the value 7. So you can combine this mask with an index operation as well, and when you do that, it returns a series where only the items in the same position as true are returned. So if you do, say, so now you see only the index or the element where this mask is true is returned. So multiple Boolean operations can be combined with these operations. So let's see an example or particular instances of that. So this is the operation that you want to do, and this is the example for it. So if you want to do AND, you provide the mask conditions like A and B. So A is a mask and B is a mask, and you can provide AND in between them to merge multiple conditions, and then you pass in with the series object to filter those values. You can do the same for OR with the pipe symbol, and then for NOT you can use the tilde symbol. So just a note to consider when you are using Boolean operations. Just be aware of operator precedence to avoid enclose all your operations in parentheses. So what I mean by this is, let's create another mask. Okay, now we have a mask 2 where we want George to be less than equal to 2. And if we put our both masks, so I want mask first mask as the first condition and second mask as the second condition. So now we looked at the index, right? And what we did here is, since it's a very simple example, the conditions did not conflict with each other, but it takes off operator precedence in the sense, if this mask is true, since it's an OR operation, it does not matter whether the mask 2 is true or not. It will give you the results for a mask anyways. And the same applies for AND condition. If this mask is false, it doesn't matter if the mask 2 is true or mask 2 is true or not. So just keep in mind of all those things. So now we looked at the index, and through index operations we can pull out values of a series. And because you can pull out values both by position and label, indexing can be a little complicated. So using .log and .iloc allow you to be more explicit about indexing operations, and we can also use slicing to pull out values. And additionally, we can also use Boolean arrays to filter the data. So I hope you got some value out of it. I know that it's not a lot in context of Pandas series and their availability of operations, but these are very basic things that you should be aware of whenever you are going to do data pre-processing or working with any kind of data in any sort of problem solving.